Hello all, we are Team Baby Coda and we are presenting our solution TA-Lite. We are here to build a virtual academic assistant designed to enhance student learning and support educators using AI. In large classrooms, students often hesitate to ask questions due to the fear of judgment, while professors face repetitive doubts around exam and assignments. This leads to communication gap, disengagement, and shallow learning experiences. TA-Lite is our answer to this. It bridges the gap between students and teachers using an always available AI assistant. It's guided, not just responsive, and helps students learn by thinking instead of copying. We designed TA-Lite as a dual portal system. Professor configure how the AI behaves, and student gets personalized, course-aware help. It's more than a chatbot. It's a learning companion aligned with the classroom. Our architecture includes separate portals for teachers and students. Professor upload the course material, configure the prompt behavior, and access the analytics. Student get guided responses, summaries, and notes, all tailored to the contents uploaded. We use a vector database to vectorize all the contents uploaded by the teacher and to allow RAG access these content. Teacher portal provides full control, upload material, set the tone and the depth of responsive, and view the engagement analytics. The student portal is intuitive. The student asks question, generate summary, and create notes, all aligned to what's being taught. We have broken down functionality into specialized agents for summary, for note making, fetching extra references, tracking confusion points, even helping with the exam prep. Each one is modular and optimized for its specific task. We had to take some important design decisions. So we gave the control to the teacher. They defined the prompt, effectively shaping the AI's behavior. We used RAG for doubt solving and direct file context for summaries and notes. We applied chunking and re-ranking to optimize retrieval. So here are some observation and insights that we got during our development. Prompting. Here's where the real challenge came in. Getting the AI to produce meaningful guided answers instead of vague responses. Initially, we used a generic prompt and the response were disappointing. We refined it by emphasizing structure, adding explicit rules like respond with a hint, not the answer, and prioritize those rules. Markdown formatting helps with readability and emphasizing instructions improve the model compliance. Here's a screenshot of how our final prompt looks like. On the RAG side, we found that the model was ignoring slide content because transcript had more matches. So we cleaned the data to remove fluff like timestamp and the speaker names, and we adjusted the chunk size based on the data format. Smaller for the slides, larger for the transcript. Here is an example how our RAG system was performing for a particular query where we asked what is PEF. The first screenshot is of initial answer and the second screenshot is after refining. In the first screenshot, you see the full form of PEF, it is incorrectly mentioned, while in the second one, we see it is accurately getting what PEF is and it also generated a much better answer. This is how cleaning helped us. Initially, if you see the transcript had larger chunk size, but after cleaning, the number of chunks reduced. Similarly, for chunking, we used a 1500 chunk size for doc file, while we used 1000 chunk size for PDF. To fix source bias, we introduced re-ranking after retrieval so that both slides and transcripts are equally considered. This re-ranking script greatly improved answer quality, and we verified this with the user testing. Coming to evaluation, I think evaluation was the toughest part for us. Generative models don't have binary outputs. We relied on peer validation, tested hint quality, and highlighted the source transparency to build trust. Feedback showed that the user appreciated the guided approach and short summaries. So here are some of the feedbacks that we received. Here is an example where we list down all the sources to build the trust with the user and allow the verification of the answers that are being generated as well. So what we have achieved in this project, we have built a strong foundational application of LLM in education, enabled professor-driven AI customization, promoted constructive use of AI in academics, and created an healthy thought simulating learning environment for students. For the future scope, we plan to implement a lecture to podcast conversation, gamification of learning, exam and assignment integrity, and domain specific agents such as a code agent for debugging code explanations. Thank you, and we are open for questions.
Let's start with a quick demo of our proof of concept. So we have two parts of our application, one designed for the instructors and another designed for the students. So let's start with the instructor part first. So this part allows the instructor to set some preferences regarding to how the AI system should help the students. So we have the we select one primary goal that we're focusing on, and then select how important student autonomy is, and then we have a few parameters according to how the AI should respond. I think this is one of our core functionalities. So the instructor can choose if they want only hints, or they want direct answers, or if they want the system to ask them thought-provoking questions and then evaluate their responses. And we also have a rank-based system that refers to the course content and then tells the students where each certain part is referred from and also gets information from there. And we also have a system that fetches external resources from the internet. We also have an option to have adaptive depth of explanation here. So depending on the student's level of understanding from their questions, which are stored in a database, these are queried, and then the level of understanding of the student is judged and the responses are tailored to their level of understanding. And we also have a setting where we can ask the agent to give direct responses or still lead them on with hints when a student is confused. So from all these inputs, a prompt is generated, which is then passed to LLM, and we display this prompt as well to maintain more transparency. And the other part of this application is to upload class materials like lecture transcripts or lecture slides. And we also have a section where we show some analytics. We show what kind of questions the students are asking and how the system is helping them, and we show a few key metrics according to what kinds of questions are being asked, and we also show a small graph. This is all also processed by a AI agent from the queries and responses that are generated, which are stored to a database. Now let's move on to the second part of the application. This part is dedicated for the students. So we have three functionalities here: to get a lecture review, to solve your doubts, and to test yourself and get ready for an exam. So the first part here is a lecture review. Here we have a menu to select the lecture to go through, and then once you select a lecture, you're prompted to pick this lecture slides or the lecture transcript. Let's go to the lecture slides. You can either generate a summary to prepare and revise for an exam, or generate study notes to get in detailed explanations. Let's try out generate summary for now. This passes the lecture content from the lecture slides or the transcript as selected, and then processes it using a LLM by passing it as context. And here you have a summary of the lecture slide. Now let's move to the next part of the application. This part is to help you solve your doubts and questions. So here you can ask a question and the agent will give you responses as per the instructor settings. So let's use one of the sample questions from a exam. So here you go. It explains a little about how LoRa works and then asks a question. And then also gives you some resources from the internet, and it also tells you where these sources were pulled from the lecture content. And you can answer this question, and then it will further process your responses to pose more questions. So let's try and answer this. and then you get more responses. It asks you to refer to the lecture slides and then poses more questions. Gives you more resources again. The next part of this section is to test yourself, to test your readiness for an exam. So you can give it a topic you want to learn more from, and it can give you some questions for you to test yourself. Let's start with one. Here you can answer this and it will provide you with feedback for this question.